All right, we're going to take what we did last class and now do this with definite integrals. And so now we have a lower and an upper value to evaluate this limit at. And so what's really cool about this is that now we can rewrite our integrals all in terms of u and evaluate them in terms of u and not have to kind of change the game and put them back in terms of x. So let me show you what that looks like. So let's say that we have the integral from 0 to 1 of x multiplied by x squared plus 1 all to the third power dx. This right here is my inside function, and so that's what I'm going to let equal u. So I'm going to say that u equals x squared plus 1, which means du equals 2x dx. All right, now I have a lower and an upper limit of integration. And so I'm going to say that a equals 0 and b equals 1. And now what I'm going to do, right now these are written in terms of x, but instead I'm going to write them in terms of u. So I'm going to say u of 0 equals, and I'm just going to substitute this 0 in for x in my u expression. So I'm going to have 0 squared plus 1, so u of 0 equals 1. I'm going to do the same thing for my upper limit of integration. I'm going to have u of 1 equals 1 squared plus 1, so u of 1 equals 2. So now I'm going to go ahead and rewrite this integration. This equals the integral now from 1 to 2 of, I'm going to go ahead and put u in just like we did before. And notice I have a 2x. So as a reminder from last class, I went ahead and I slid a 2 right here, which means I need to multiply by 1/2 because 1/2 times 2 equals 1. So the same rules apply for what we did before. So I have my 2x dx, that's my du, and I have my u to the third power. And so now I have that rewritten in terms of u. And so because I changed my lower and upper limit of integration to be in terms of u instead of x, I can now just take the integral of this in terms of u and evaluate it. So now I can go through. I'm going to add 1 and then multiply by the reciprocal. So 1/4 u to the 4th evaluated from 1 to 2. So I get 1/4 times 2 to the 4th, subtract 1 to the 4th. And then I just keep on evaluating. And I have 1/4 of 16 subtract 1, which gives me, oops, sorry, I forgot my 1/2 out here. Thought something was missing, times 1/2. So I have 1/8 times 15, which gives me 15/8. I apologize about that. I forgot to rewrite this 1/2 over here when I rewrote it in terms of u. All right, let's try another one. We have the integral from 1 to 2 of 3x squared plus 1 all over x cubed plus x dx. All right, these ones can be a little confusing sometimes because they both just look like expressions, right? And so we always want to look for our larger degree because when I take the derivative of that, what I'm going to end up with is something in terms of a lower degree of the other expression. So in this case, notice that my inside function is going to be that x cubed plus x. So I'm going to go ahead and let u be x to the third plus x, because then du is going to be 3x squared plus 1 dx, and notice that's that guy right there. So I have my u and I have my du. So far we know we have an integral 1 over u times du. Now I need to change my lower and upper limits of integration. So I'm going to go ahead and say u of 1 equals, so I'm putting my a value in first, 1 to the third plus 1, which is 2. Then I'm going to do u of 2, which is 2 to the third plus 2, which equals 2 times 2 is 4 times 2 is 8 plus 2 is 10. So I'm going from 2 to 10. I know that in order to take the derivative of 1 over u, if I were to make that u to the negative 1 and add 1, I'd get u to the 0. My brain short circuits and I say there must be something else. I take the derivative of natural log to get 1 over u. So my antiderivative of 1 over u must be the natural log, but we do the absolute value to make sure that my domain restrictions are solid. Then we're evaluating this from 10 to 2. And so we have the natural log of 10, subtract the natural log of 2. Since those are both positive, I can just get rid of the absolute value. And then my quotient rule for log says that the natural log of 10 subtract the natural log of 2 is the same as the natural log of 10 over 2, or the natural log of 5. A little simplification there at the end. All right, let's try one. Nope, I think that's actually it. Yeah, we're going to leave it at that. So you guys have a delta math. And again, notice the only thing that's changed here is that we are now having a lower and upper limit of integration. All right, sorry about being absent. Hopefully I will be back tomorrow. I know you guys won't have class tomorrow, but you can always pop in tomorrow morning if you have any questions. Or send me an email with your work and I can provide some feedback. Bye, guys.